So I wanted to go over how to do this chemistry problem. So first off, it's the number of variables will be the number of components or uh, elements that we're having. So this is x4. So our solution, come back. Our solution x will be 1, 2, 3, 4, because there's, that's a 3. So there's 1, 2, 3, 4 things that we're trying to balance. Okay, so we put the x1 in front of the vector, and we have to make the vector from these elements, and I did tell you what to put in here. And so this is 3 of the sodium, and I'll just let you kind of evaluate. You have to be careful that you don't make a mistake with getting the number of elements in each. So in this here, 0, 0, 6, 1, 2, I think most of you got this part. It was just a matter of the next step. So I just want to make sure you know how to do this. Plus x4, and then I get 1, 0, 3, 0, 1. Okay, so the next very important step is that you want to subtract these two elements, right, over to the other side. And I'm going to take 2 steps in one, because you know once you subtract those over, you're going to get it equal to 0. And so I'm going to put together the augmented matrix. So I'm going to put my column of zeros here. So there's 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Then I'm going to put this vector here, and this vector here. And then remember, these two are getting subtracted over. So I'm just going to emphasize that and make sure that you put negatives in front of these ones. So I get a -1, 0, -3, 0, 1. Okay, the next step is where you put it into your calculator and put RREF. So make sure you've got your calculator working and you do it. So then I get 1, 0, 0, -1/3, 0. And I'm just going to copy down what I get. So make sure you can get your calculator to do this. If you enter it wrong and it gives you error, that means you entered it wrong. You made a mistake somewhere along the way, because I am not going to give you a chemistry equation that won't balance. Okay, so let's make sure we know how to get the information out of here. Okay, so let's take this first row. So this first row here says x1 minus 1/3 x sub 4 equals 0. Okay, this second row here says x sub 2 minus 1/2 x sub 4 equals 0. And then this one here says x sub 3 minus 1/6 x sub 4 equals 0. Okay, so then take these and solve them for their basic variables. So these 3 are the basic variables. So I'm going to put it over here. x1 is 1/3 x sub 4. x2 is 1/2 x sub 4. And x3 is 1/6 x sub 4. So that I make up the vector x, and I've made mention of this in the videos. It's really useful to just give yourself context. Oh yeah, there's 4 variables, right? Because there's 4 things we're balancing. So then we substitute in what I have from here, right? From this column. So I get a 1/3 x sub 4, a 1/2 x sub 4. Oh, I'm sorry. Yeah, 1/6 x sub 4, and then x sub 4 is just itself. So then if I factor out the x sub 4, I get 1/3, 1/2, 1/6, and 1. Oops, 1/6, 1/3. Okay, so solutions are in the span of this. So that means I could multiply this vector by 6, or any number, right? That's what the x sub 4 means. You can multiply it by any number. So I'm going to take this vector, and I'm going to multiply it by 6 to get 2, 3, 1, 6. So the answer would be the balanced equation. So you would have 2 in front of the first element, the Na3, PO4, and then you would have the number 3 in front of the second element. And I'm just going to run out of room. And so it'll be 2 words, 1 in front of this third element, and then 6 in front of this next element. Okay, So that's the first one. And so the answer truly is this balanced equation. I just ran out of room. All right, so to find out whether vectors are, or the columns are linearly independent, you always want to think about context. Because there are 3 columns, there are 3 variables, right? And so when you're thinking about free variables or all that stuff, you want to keep in context of how many variables there are. 3 columns means 3 variables. So you know that if you solve ax equals 0, right? And I find out if I have only the trivial solution, then it's linearly independent. So if I put this in my calculator with augmented with zeros and then hit RREF, I get 1030, 0, negative 140, 007, 00000. Okay, this last row of zeros does not mean infinitely many solutions because there are 3 variables, and if I look, I have 3 pivots in the original matrix, right? Because I'm only augmenting it with 0 to see if there's only the trivial solution. And I didn't even go further to go RREF. I stopped there. I could have gone and put it in RREF, but I can see that this says, this third row here says 7x sub 3 equals 0. Oh, so x sub 3 is 0. And then this one here says negative x sub 2 plus 4x sub 3 is 0. Well, I know x sub 3 is 0, so I get negative x sub 2 is 0. So x sub 2 is 0. So I get only the trivial solution. And I can also see that there's a pivot in every column and of the original matrix A, not the augmented, a pivot in every column of the original matrix. So that makes it linearly independent. Okay, so this one here, lots of people got it wrong, so I want to make sure I go through all the details. So yet there's 2 equations to solve, right? First, there's the homogeneous. The homogeneous, you know, always has the trivial solution, right? That means if you put in the x vector of x1, x2, x3 equaling 0, 0, 0, it works, right? That's the trivial solution. So we're interested to see if there's a non-trivial solution. Okay, so we take this and we put it into our matrix. 1, 3, negative 5, 0. 1, 4, negative 8, 0. Negative 3, negative 7, 9, 0. Then we do our RREF, right? I'm assuming you can put this in your calculator. You won't have time to do all of the row operations on the test. It's going to take way too long. So I want you to get to the heart of the problem solving instead of just, doing the computation. All right. This first row says x1 plus 4x3 equals 0. And the second row says x1 minus 3x3 equals 0. You must go further for the solution. So, x2. That's x2, right? Okay, so now you solve for your basic variables. Those are the pivots. The pivots are your basic variables. So x1 is negative 4x3. x2 is 3x3. Okay, so I'm going to come down here. So I'm going to solve for my x, which is x1, x2, x3. So I substitute these in. So I get negative 4x3, 3x3, and x3 is itself. So my solution x is going to be, if I factor out, if I factor out the x sub 3, I get negative 4, 3, 1. So solutions for the homogeneous would be the span of this vector, negative 4, 3, 1. Okay, that's the homogeneous. So now we're expecting the non-homogeneous to be a point plus that vector. Okay, so I got to erase this. Whoops, got to erase this to make room, but you've got it and you've already seen it. Okay, so now I'm going to put this in a matrix, right? So I get 1, 3, negative 5, 4, 1, 4, negative 8, 7, negative 3, negative 7, 9, negative 6. Okay, so then I RREF it. So I get 1, 0, 4, negative 5, 0, 1, negative 3, and 3, and then a row of zeros. So then be able to pick out the information. So I'm going to erase this because you don't need this anymore. Whoops, erase this one. You don't need this. Okay, so let's figure out what these rows are giving us. So the first row gives us x1 plus 4x3 equals negative 5. Remember, because it's the augmented. So the second row, the second row gives me x2 minus x sub 3 equals 3. So you solve for your basic variables, right? These are my basic variables. So x1 is negative 5 minus a 4x3, and my x sub 2 is a 3 plus a 3x sub 3. So I still do the same thing. Start off with x1, x2, x3, and I factor out the x3. Whoops, no, I better go slower than that. Okay, so then I'm going to put in what the things are. So x sub 1 is 5 minus 4x sub 3. X sub 2 is 3 plus 3x sub 3, and x sub 3 is itself. Okay, so now I'm going to separate it. So I've got some numbers times the x sub 3 vector, and then I've got other points. So I've got to separate them. So I'm going to take this 5 and 3 and put them here, and then I have to have a placeholder here, and then I'm going to put over here the negative 4, the 3, and the 1. So the span vector from the homogeneous should be the same vector it is, and it has a point added to it.